to make sure that we have it. So let's put that on our next page and we'll label that special power properties. Okay, so one that's very important is our zero property, zero power property. Okay, so in our zero power property, what we're saying is, if I have my base, can be anything, raised to the zero power, I end up getting 1. That equals 1. So the question is, why is this? Okay, well, let's think about this for a minute. Let's just take some number. Let's just say 4 divided by 4. Okay, just for the fun of it. So if I have 4 divided by 4, we all agree that 4 divided by 4 is equal to 1, right? Okay. Well, isn't 4 divided by 4, don't I have an exponent of 1 here and an exponent of 1 here? So that's 4 to the 1 power divided by 4 to the 1 power. So aren't we dividing the same base? So we divide the same base, we subtract exponents, right? So that would mean that this would be 4 to the 1, and if I bring that up, I'm going to subtract it. So that's going to equal 4 to the 0. So we agreed that 4 divided by 4 is the same as 4 to the first power divided by 4 to the power of 1, right? These two are equal. So if 4 divided by 4 is 1, then that would have to mean that 4 to the 0 power is also equal to 1. So that's why that works out like that. Okay, so one last one, and then we're done with this. And that would be the negative power property. What you have to be careful with the negative power property is that negative is actually telling you to do an operation. It is not an integer. It's telling you to take the inverse or the reciprocal of a number. So if I have my base A and I'm going to have it say to the negative n, well, what does that mean? That means this negative right here in that exponent means take the inverse. Inverse is another word for reciprocal. Take the reciprocal or the inverse of something. Okay? So we would read this to say, take the inverse of a to the n. Okay? Notice when I say take the inverse of a to the n, that negative is not there anymore. Because that's what that negative is saying. Take the inverse of. That's what that means. Okay, so let's see what that would look like. So if I have a to the negative n, that's going to equal, that's going to go downstairs in the denominator because we have to take the inverse of a to the n, so then it's going to be a to the n. Notice there's no more negative sign in front of that exponent. It's where it wants to be. Okay? So let's look at this as far as, the other way. The other way to do it would be if I had 1 over b to the negative n. Well, what would that be? Well, this is saying take the inverse of b. Well, b is in the denominator, right? So technically what that would be is 1 over b. And so what's happening here is that's a division problem. So that's the same as 1 divided by 1 over b, which is the same as 1 times b, which would equal b. Okay? So that's technically what we're doing here. But we're going to take the inverse of that, which just brings everything upstairs. So that means then that's going to be b to the n. An easy way to think of this too is when the exponent crosses the line, the exponent changes its sign. So notice, what's our line here? Well, we have a denominator. There's always a denominator of 1 if it's not written. So notice when the exponent crossed the line, our division line, our exponent became positive. Same thing here. In this case, it went from the denominator to the numerator. Okay? So let's look at this as far as numbers go. If I have negative 3 x to the negative 2, sorry, I mixed my numbers, colors up, didn't mean to do that, y to the negative, to the 4. Okay, well, let's look at what we're saying. Does negative 3 have any exponent to it? No. That negative 2 exponent is only going to the x. So nothing's happening to that negative 3. So that negative 3 wants to stay in the numerator. So we're going to put it in the numerator, leave it in the numerator. So this is x to the negative 2. Well, this is take the inverse of x squared. So the inverse of x squared would be putting my x in the denominator. The other way of looking at that is my x has crossed the line, so the exponent changed its sign. Now, my y to the 4th, nothing's happening there. There's no negative sign there. So my y wants to stay where it is, and my exponent stays where it is. So that's how we do that. Okay? So another example, another numerical example, would be if I had 2 divided by x to the negative 2. Okay, so let's look at what we have here. I have a 2. Where is it? It's in the numerator. It wants to stay in the numerator, and nothing's happening to it. So I'm going to leave it where it is. Okay? Now my x, what's happening to my x? This is saying take the inverse of x squared. Well, the inverse of x squared means I'm going to put that x from the denominator into the numerator. So I simply get x squared in the numerator. Notice the x negative 2 crossed the line, so the exponent changed its sign. And that's the negative property. And that's all the properties that you need to know, and you can use them in any sort of combination necessary to solve or simplify